All right, this is section 3.5, transformation of graphs. We start with what we call the parent graphs, which means graphs that we know something about, in particular, the location of points relative to one of the points. So we look at the first one, which is y equals x squared, or we can say f of x equals x squared. Notice that's the squaring function. It's a parabola, right? If you remember, for a parabola, when the a equals 1, do you all remember a x squared? That's 1. All right, so if it's 1 from the vertex, well, first of all, the vertex at 0, 0. And then from the vertex, you go 1 to the right, 1 up, 2 to the right, 4 up. And then I also know 3 to the right, 9 up. And how do I know that? Well, when I go to the right, I just square that number and go up. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Same thing to the left. 1 squared is 1, 2 squared is 4, 3 squared is 9. And notice each time I arrive at a point on the graph. Okay, so that's f of x equals x squared. The second one is f of x equals the square root of x. It's right here, by the way. It's just written y equals the square root of x. But we want to think of it as f of x equals the square root of x, called the square root function. Okay, and you start at 0, 0. It's not called the vertex, I don't think, because it's not like this one. But let's call it a starting point. From there, you go 1 to the right, 1 up, and there's a point there. From the starting point, 4 to the right, 2 up, and from the starting point, 9 to the right, 3 up. Now, how do I know the 9, 3? Well, it's a square root function. And similar to the squaring, where I go 1 to the right, square 1, you get 1, square 2, you get 4. Here you square root 1, you get 1, square root of 4, you get 2, square root of 9, you get 3. And I also know there's 1 16 to the right, 4 up, because the square root of 16 is 4. Okay? All right. The last one is the absolute value function. F of x equals the absolute value of x. All right. And this one, same thing. You have some reference points. This one does have a vertex, right there. Okay? At 0, 0. And then from there, notice I go 1 to the right, 1 up, 2 to the right, 2 up, 3 to the right, 3 up, 4 to the right, 4 up. And same thing left. 2 to the left, 2 up, 4 to the left, 4 up, 6 to the left, 6 up. Okay? All right. Now, and for each of these, a is 1. You remember the leading coefficient is 1 here, and 1 here. Okay. Let's look at vertical shifts, and we're going to identify these just from the way the function looks, the function that we're given, or the equation in this case. So vertical shift, suppose f is a function and c is greater than 0, y equals f of x plus c moves f of x up c units. Yeah? Plus c means like plus 2 or plus 1. And minus c means like minus 2 or minus 1. Now, this is what you... well, let's read the next one. Horizontal shifts, f is a function and c greater than 0. F of x plus c moves f of x left c units. And y equals f of x minus c moves f of x to the right c units. Okay, now, you want to notice the following differences. On the vertical shifts, the plus c or minus c is outside the argument. That means outside of where the x is. Yeah? And for the horizontal shifts, the plus c or minus c is inside the argument, or inside the parentheses. They also work kind of intuitively when it's outside the parentheses, outside the argument, right? Like plus c means c up, and we associate plus with up, and we associate minus with down. But on the horizontal shifts, well, you're working horizontally, right, left and right, and also counterintuitively. So plus doesn't move you to the right, plus c moves you to the left, and minus c moves you to the right. Okay? All right. So let's take a look at these. Let's do an example of each. So let's do example number 1a and 2a. So we're going to identify the shift, and then we'll just apply the shift. Okay, so y equals the absolute value of x plus 3. So the function f of x, you know how it's written up here, f of x plus c? Our f of x here is the absolute value. That means that's the shape we're working with. That's all it means. And we're going to move that plus 3 outside the argument. That means outside the absolute value. Well, let's go back to that. So for these, outside the argument is outside each of the symbols. So outside the absolute value, outside the square root, outside the squaring. Inside the argument means inside the squaring. That means the c is being squared also. Inside the absolute value, inside the square root, inside the absolute value. Okay, inside the argument, inside the absolute value. Outside the argument, outside the absolute value, or outside the square root, and so on. Okay, so this is outside the absolute value. That means outside the argument, so it follows this. Plus 3 means 3 up, and it's the absolute value function, which is this one, shifted 3 up. So I'm going to shift the vertex 3 up. 1, 2, 3. Here's my vertex now. And then I'm just going to follow the pattern. 1 to the right, 1 up, 2 to the right, 2 up, 3, 3, 4, 4. Same thing to the left, 1, 1, 2, 2, 3, 3. Okay, so 1, 1, 2, 2. Notice I start at the vertex all the time. 3, 3, 4, 4. And same thing to the left. Yeah, and of course, notice you could also just follow that slope 1 and negative 1. There's my y equals absolute value of x plus 3. Let's try number 2a. So this one's a minus 2, but it's inside the argument, so it means it's a horizontal shift. Yeah? Counterintuitive, so I'm going to move 3 to the right. Counterintuitive, 3 to the right. Let me write it here. Little note. And it's over here. Let's indicate to ourselves it was 3 up. Okay? Absolute value 3 up. This one, which of these functions is it? Well, that tells us it's the squaring function, the parabola, 2 to the right. 2 to the right, I'm sorry, I wrote 3. 2 to the right. So I'm going to move the vertex 2 to the right. Yeah, and our A is 1, so I'm going to follow the pattern from the vertex 1, 1, 2, 4. Right, I'm going to try to get 3, 9, 3. That's 4, 9 here. Okay, same thing the other side. 1, 1, 2, 4, 3, 9. Notice it's not really the coordinates 3, 9. It's 3 to the right, 9 up, 3 to the left, 9 up. Okay, and fill in my parabola. So my parabola goes something like this. Nice curving. Nice curving. There we go. Okay. All right. Let's look at some other moves that we need to learn to make. So, well, some other problems we need to learn to do, I guess. So again, this follows vertical and horizontal shifts. So let's do number 3, and we'll leave number 4 for class. And same thing with the other one. We'll leave the other 2 examples for class. Okay, those 2 examples right there. All right. So this has more than one shift. Notice this is the squaring function. So it's a parabola. A is 1. The minus 3 is inside the squaring. That means inside the argument. So it works horizontally. And it's counterintuitive. So this will be 3 to the right. And this one is outside the argument. That means, as it says, 4 negative means 4 down. Okay, so I'm going to move the vertex 3 to the right, 4 down. From 0, 0. 3 to the right, 4 down. There it is. And then, because A is a 1, it just follows that pattern 1, 1 to both sides. 2, 4 to both sides. 3, 9 to both sides, right? 3, 9. There you go. Okay, oops, I'm sorry about that. It's 3, 9. Okay, and I'm just going to connect them, try to be as smooth as possible. There we go. There's my parabola. Okay. And then I'm going to let you guys do that. Okay. Notice it's a good idea to make note of your shifting. All right. And number 5 and 6, we need to write the equation. So let's do this one. This one is the square root. I don't know if you can identify it. So this is the square root shifted 1 down. Right. So it's f of x equals square root of x 1 down. Okay, so 1 down means it's a minus 1 outside the square root. So this will be y equals square root of x minus 1. All right, let's start the next part here. So reflections, that means flipping upside down or across this way. Okay, horizontal reflection, vertical reflection. Okay, The first one, y equals negative f of x, is a vertical reflection. That means when the negative is outside the argument, it's a vertical reflection. So you're going to flip this way or that way, whichever way is necessary. And the second one, y equals f of negative x, is a horizontal reflection. So it's from left to right or from right to left. All right, let's take a look at the example here. Y equals square root of negative x. So that's a square root function, and the negative is inside the argument, so that's a vertical reflection. Vertical reflection. All right, so usually your square root starts at 0, 0, and you go 1 over 1 up, 4 over 2 up. But if I reflect, horizontal. What did I say? Vertical. Horizontal reflection. I'm sorry about that, because it's this one, right? The negative is inside the square root. All right, so usually you're going in this direction. Now you're just going to flip it the other way around. So it's 0, 0 still there, because when you flip it around, still there. But 1 to the right, 1 up is 1 to the left, 1 up. 4 to the right, 2 up is 4 to the left, 2 up. And then 9, 3, well, we don't have enough place to put it. Just make sure you, let's see, this would be 4. Yeah, it'd be pretty far out that way. Just make sure you don't cross 3, right? Because you can't cross it until you get to negative 9, 3. All right, that's the square root function pointing in the other direction. All right, and I think I'm going to stop here. We'll continue with the other part on the second part of this, which will be vertical stretching and shrinking, horizontal stretching and shrinking. All right, outside the argument, vertical, inside the argument, horizontal. We'll pick up on the next part.